So far, in our study of linear equations, we've dealt with a single linear equation, which to review is an equation that has two variables and produces a straight line with a constant rate of change. But often we need to compare two sets of data, so we'll be comparing two linear equations. When we put these together, it's called a system of linear equations. It's a set of equations that work together. They are dealt with at the same time. So far, you've been writing and solving single equations. Now you will be writing and solving two equations at the same time. Your goal is to find a single solution that fits both equations. I like to think of it as a Venn diagram. Your first linear equation represents this circle, so all of the solutions as ordered pairs would fit in this circle. Your second linear equation is represented by this red circle. Again, it has its own set of ordered pairs. If there is a single solution to your system, then it's going to be represented in purple here by a single ordered pair that exists on both lines. So let's start by writing some systems. Write and solve an equation for each situation. All right, first Nina purchased 4 pounds of strawberries for a total of $6.40. How much did she pay for 1 pound of strawberries? Okay, so we're just going to write this as a linear equation. She has 4 pounds of strawberries, so that's 4 each. And I'm just going to use X as my variable. And the total is $6.40. How much did she pay for 1 pound of strawberries? We could divide by 4 and find that 1 pound, or X, is $1.60. Nina purchased 5 pounds of apples for a total of $9.95. Since this is my second linear equation, I'm going to switch colors. So 5 each. Remember, X is our variable for pounds. And the total is $9.95. How much did she pay for 1 pound of apples? So again, I'm going to divide both sides by 5 to find that 1 pound is $1.99. So there's nothing new here. This is everything that you have done before. So we're just going to build on to what you already know. Let's go to the next page. Let's write a system for this scenario. Nina purchased apples and strawberries. She purchased a total of 9 pounds of fruit and spent a total of $16.35. Strawberries cost $1.60 per pound and apples cost $1.99 per pound. How many pounds of each type of fruit did she buy? Now, this is a very common type of system of equation question. So first, I want to highlight what we're looking for. You're going to have two equations. One equation represents the amount of fruit she purchased, and a second equation represents the cost of the fruit. So we're going to separate these, and I'm going to use highlighters of two different colors. So first, for the amount of fruit purchased, I'm going to do that one in red. So I'm going to do the amount of fruit in red. So how much fruit? She purchased a total of 9 pounds of fruit. So that's going to be the amount. And the second information, the equation that represents the cost of the fruit. So here we're looking for anything that has a dollar sign in it. She spent a total of $16.35. Strawberries cost $1.60 per pound, and apples cost $1.99 per pound. How many pounds of each type did she buy? Okay, I'm going to start with the cost one. This one seems to be a little bit simpler for students. The first thing I'm going to do is define my variables. Now, since we're doing strawberries and apples, you can use S and A, but just for consistency, I'm going to use X and Y. So the first thing I need to do is define my variables. What is X going to be and what is Y going to be? So I'm going to call X my strawberries, and I'm going to call Y my apples. It's important to always define your variables so that the reader, whoever's checking your work, is clear on what you're talking about. So let's now look at the cost of the fruit. Strawberries cost $1.60 per pound. So that's $1.60 per pound of strawberries, which we said was X. Apples cost $1.99 per pound. So that's $1.99 Y. And the total is $16.35. Now we know that a total in the cash register is found by adding those together. So that's the cost equation. Now the second one is the amount of fruit she purchased. We know the total is 9 pounds. But the total of what? How many strawberries and how many apples? So our strawberries and our apples all together is 9 pounds. So those are our two equations. Let's do another similar problem. Jay is selling tickets to a football game. He sold 21 tickets for $486. A first section ticket costs $30, while a second section ticket costs $18. How many of each type did he sell? All right, let's first highlight what our two equations are going to be. Remember, we need an equation that represents the number of tickets sold and a second equation that represents the cost of the tickets. Again, this is very common where one equation is an amount and another relates to cost. So in our problem, we're first going to look for the number of tickets sold. So it says he sold 21 tickets. That's it. That's all we know. Second, the cost of the tickets. The total is $486. A first section ticket is $30. Second section is $18. And how many of each did he sell? All right, let's remember to define our variables first. So I know I have a first section and a second section. So I'm just going to say X is the first section and Y is the second. All right. The number of tickets sold. We know first and second section tickets together, he sold 21 tickets. So that's X plus Y is 21. The cost of the tickets, the first section was $30. So that's 30 each, or 30X. And second section was $18. So that's 18Y for a total of $486. If you're struggling to find the two equations, try to use some color coding strategies to separate the information into the two parts and find your two variables.